Hello mathematicians, it's Miss Cattey back today with another video. Today we're going to talk about how to find the area and perimeter of two-dimensional figures. We've already done a lot of these in class before we left for spring break, and we're going to go over those a little bit more, review them really quick, and then we're going to get into some figures we haven't done yet this year. Every single shape we're going to talk about we have either covered this year or you learned about in 8th grade. So largely today is a review so that Wednesday, when we get into something a little bit new, not really new, you'll have a little bit of an idea of what we're going to do. So a two-dimensional figure is a flat shape. It is something that we can put on a piece of paper. My phone is not two-dimensional because it's thick here, but the little rainbow on my pop socket is because it's flat. That's a 2D shape. So we're going to cover 8 different shapes today. Now let me show you my screen so that we can go over the difference between area and perimeter. When we are talking about area, that is going to be the inside of the shape. So I'm going to use blue for my area. And then I'm going to use red for perimeter of this shape. Now the area of the figure is this inside portion. If I want to find the area of this star, it's all on the inside. This decagon has got a funky shaped area, but it's the inside nonetheless. The perimeter is the outside. That is, if I were traveling along the edges of this figure, that is my perimeter. Areas. The inside perimeter is a length. This is the outside length of the figure. Every single side added together in that shape. So if I want to find the perimeter of any two-dimensional figure, we can add up all its sides. And the ones that we can't, such as a circle, they have their own formula for that perimeter, and we call that a circumference. We'll talk about that in a minute. Now I'm going to mute my video and pull this up so I can hold this as more of a flat surface and it's easier for me to write on. First shape we're going to cover is a triangle. We have done this year already many times. So the area of our triangle is 1/2 BH. B is our base right here, and H is my height. Keep in mind, just like when we did this in school, the height and the base have to be perpendicular. They are perpendicular lines. They form a 90-degree angle. This purple line over here, this leg of the triangle, is not the height because that is not a right angle. For this example, I'm going to just make up some arbitrary numbers. Of course, you'll be given your lengths. 6 centimeters. I'm going to call this 7 centimeters, 5 centimeters, and I think this is isosceles, so this one should also be 5 centimeters. Now, if I want to find the area of this figure, I'm going to use that formula from up there. 1/2. My base is this 6. My height is right here. It's this 7. And I should have drawn that right angle in sooner, but it's there now. So 6 times 7. Okay, I'm going to simplify that, and I'm going to say this is 1/2 of 42, which is going to be 21. Now in Google Forms, you're not going to be able to enter all of your units. Some of the questions ask you for a unit, but not all of them. In this case, our unit is centimeters squared because this is an area. Now, if we're looking at our perimeter, that's a little bit different. To find my perimeter, all I have to do is add up my side lengths. So I've got 5 plus 5 plus 6. 5 plus 5 is 10, plus 6 would be 16. Because perimeter is a length, we are not squaring that unit. My perimeter is just 16 centimeters. Even though it's not a continuous straight line, keeping going forever, that doesn't matter. Our perimeter all the way around is just 16 centimeters. Next figure is going to be a square or a rectangle. If you did that extra credit assignment that we posted, you may have already remembered this and refreshed this for yourself. But the area of a square or rectangle is just base times height. You might also see it as length times width. These are the same thing. They mean the same thing. Here's my base, and here's my height. Now you might notice that again, they're perpendicular. That's always gonna be true. Our bases and heights are always gonna form a right angle in any figure that we're using base and height in. So here I'm gonna say my base is 4, what do we used centimeters on the last one. So we'll say 4 inches and 8 inches. My area is gonna be my base times my height. And that'll give us 32 inches squared. In a rectangle, we know that the opposite sides are congruent. So my perimeter would be 4 plus 4 plus 8 plus 8, or 2 times 4 for the bottom and the top, plus 2 times 8 for the left and the right. Either way, doesn't matter. This is going to give us 24 inches as our perimeter. Okay, let's move on to a circle. This is another one we've done already this year. We did this right before spring break. So if you were absent the day before spring break, you may not have refreshed this, but again, it's a shape you did in 8th grade, so nothing new. The circle formula is going to be pi r squared. Pi is that irrational number that's infinite, never ending. If you are using the linked Desmos scientific calculator, even the iPhone calculator has pi on it. It's best to use the pi symbol so that you can get your most accurate number. If you are unable to use pi, that's okay. It's about 3.14. So anywhere you need to use pi, for now, you can use 3.14. This r is our radius. Okay, that goes from the central point of the circle out to a side. Every radius in a circle is the same length. So that radius is the same as this one, is the same as this one. They are all the same. Now I mentioned that circles have their own word for perimeter. That is going to be the circumference. This is the perimeter of a circle. Okay, it's the outside. And there are 2 equivalent formulas we can use. That would be 2 pi r, if we're going to use our radius. That's an r, sorry guys. Or pi d. D stands for diameter. Instead of just going halfway from the central point to the edge, a diameter is a straight line through the central point, goes from edge to edge, it's all the way across. So depending on the information you're given, you may want to use one of those other formulas. Now here for our example, I'm going to say our radius is 3 feet. So my area would be pi 3 squared. And I know that squaring is a number times itself. So 3 times 3 is 9. So if I then go to my handy dandy calculator, which I am just using my iPhone calculator, pi times 9, if I round to the nearest tenth, It's 28, well here, if I don't, it's 28.26. That 6 is going to cause the 2 in the tens place to round up to a 3. So I'm going to have 28.3 feet squared. That's an area. My circumference would be 2 pi r, and I'm using the radius formula because this time I'm given my radius. 2 pi 3. 2 times 3 is 6, so this is going to give me 6 pi. And again, I'm going to refer to my handy dandy iPhone calculator. Times 6 is going to give me 18.84. Rounding to the nearest tenth will give me 18.8 feet. Circumference is perimeter. Perimeter is length, so we do not square our unit there. We're going to keep it just as feet. Similar to a circle, our next shape is a semicircle. It looks like what it is. It's half a circle. It's if we took a circle and chopped it at a diameter. And the formula for area is going to be just like that. The area of this shape is half of a circle, half of pi r squared. R is the same, right here. The perimeter for this shape is going to be half of 2 pi r plus the diameter. So this half 2 pi r portion right here, this portion covers the half of the circle. The diameter right here, the plus d, is that chop off point, okay? And you may notice that we can take this formula and simplify it right down to say pi r plus d. These will cancel out. And then a fun fact you may want to keep in mind is that the radius is half of the diameter, or the diameter is 2 times the radius. So those formulas may come in handy here. Down here on our semicircle, let's say our radius is 7 meters. So the area of that is going to be 1/2 pi 7 squared, half pi times 49 is my 7 squared. 0.5 times 49 times pi in my phone calculator is giving us 76.9 meters squared. We've got an area over here. Our perimeter will be pi, 7's my radius, plus my diameter is 2 times my radius. So 2 times 7. Right here is our diameter, okay? So this is 7 pi plus 14. Back to the handy dandy phone calculator. Times 7 plus 14 gives us a perimeter of 35.98. If we are rounding to the nearest tenth, that 8 will cause 9 to round up. The only thing 9 can round up to is the next whole number, so it's actually going to round to 36 meters right here. And that is our perimeter. Notice I did not square meters because we're talking about a length. Okay, I'm not going to talk about perimeter anymore because we're adding up all our sides. You guys can do that. I'm confident in your ability to do that. Now, parallelogram area is the same as a rectangle. It's base times height. Our bases are parallel to each other. These sides are parallel. And then I'm going to use my double feathers here. These sides are parallel. This is my base, okay? And just like in every other shape with the height forms a 90-degree angle. In our example right here, whoops, that was horrible. Bet you guys have missed my horrible straight lines, huh? I'm gonna say my height is 7 inches and my base is 8 inches. So the area is 8 times 7. There's my B, there's my H. That's 56 inches squared. Okay. Next one is a rhombi and a kite. Remember, the difference here is that in rhombi, all sides are congruent. In kites, 2 sets of sides are congruent. 2 sets of congruent sides. If you want more details on that, because I know you don't have your journal with your foldable listing all the properties, let me know and I can send you a link to the foldable, or you can just Google it and you can find the difference between a rhombi and a kite. This formula is the newest one so far. 1/2 D1 D2. D stands for a diagonal. Those we talked about when we did quadrilaterals, but here is a diagonal. Call that D1. Here's my other diagonal, that's D2. They connect 2 opposite endpoints and go through the figure. So over here, in our example, I'm gonna label my blue diagonal and my red diagonal. Let's say this is 4 centimeters. And let's say this is 9 centimeters. So my area, here's D1 and D2. Remember, they're interchangeable. It doesn't matter which one we call D1 and D2 because of the commutativity of multiplication. Those numbers can flip and still be the same product. Okay, so this is 1/2 of 36, which results in an area of 18 centimeters squared. I hope you caught that. I hope you yelled at me through the phone, even though I couldn't hear you. I wanted to make sure you're paying attention. Almost done. Here's our trapezoid. Area of a trapezoid has a grouping symbol in it. We need to make sure when we are using our grouping symbol, our parentheses right here, we're not leaving them behind in our calculations. Leaving those parentheses behind will result in your area being calculated incorrectly. So make sure when you're doing that, you are using your order of operations correctly. You're adding your bases first. So here's a B1 and B2. Remember from quadrilaterals that our bases in a trapezoid are the parallel sides, not the legs over here. There are parallel sides. And just like every other shape today, the height is perpendicular to those bases, okay? And down here, let's say 3 inches. Let's say 7 inches. And let's drop a perpendicular here. And I'm gonna say the height's about 5 inches, okay? So then when I'm going to calculate my area, I'm gonna add my bases and multiply by the height. Order of operations, that grouped expression right here goes first. 3 plus 7 is 10. Then in our order of operations, we move left to right for the rest of our multiplication. So 1/2 times 10 right here is going to give me 5 times 5 is 25 inches squared. There's our area. Biggest thing, guys, make sure you're using the perpendicular as the height, not a leg. This is not a height. Last shape, we've done this one. We discovered this formula in class together, so I hope you guys remember it. A equals 1/2 little a times p. That's apothem and perimeter. Or we also used ANS. I think a lot of us preferred this second formula because it helped us remember that we want to multiply by the number of sides also. We don't just want one side. Why can we multiply by the number of sides, Miss Cattey? Why don't we have to add them all up? Remember, the definition of regular means all sides are congruent. So we're able to take this multiplicative shortcut here instead of having to add them. Think of our dodecagon. Would we want to add the side to get itself 12 times? No, we would want to be able to do that multiplication shortcut because we've got that congruence here of all sides. Okay, I'm going to label our figure real quick. Here's my apothem, here's my side length, and then n is our number of sides. Last example, I'm going to drop my perpendicular apothem. Yes, remember, the apothem is the perpendicular. This other guy is our radius. We don't need him. Okay, so here's my apothem of 2. I'm going to get spicy. I'm going to leave out a unit. We don't need units for this one. And I'm going to say my side is 6. Now I've got to say I know this is congruent. They're all congruent. Can't make that up on your own. I can make that up because I'm giving you an example, but you are going to use the information that's given to you. Now, one piece of information that's given to us but not explicitly written is n. Number of sides is 5, which means this is a pentagon. This guy is a pentagon. So for my area, I will use 1/2. My apothem is 2. My number of sides is 5. And my side length is 6. So 1/2 of 2 is 1. Those cancel. 5 times 6 is 30. And I didn't put a unit, but I can say units squared. I don't know what my unit is, but whatever it is, it's got to be squared because this is area. Okay? Now, if you were asked for your perimeter, here's your perimeter. It's the number of sides times the side length. So in this case, our perimeter is also 30 units. Okay, those are all our formulas. Those are all our figures. Here are some of our major takeaways that are going to be really important from today. Things I want you to make sure you are being careful of when you're doing these problems. The height of your figure is always perpendicular to the base. They make that nice 90-degree angle. A lot of the time you're going to have a leg or you're going to have another side of that figure that is not perpendicular. Be careful. Stop. If I'm using height, am I perpendicular? Next is the area is going to use those squared units. So you're going to have inches squared, meters squared, miles squared. You're going to have squared units. On the other hand, perimeter is going to be a length. So we're going to have centimeters, meters, feet, not squared. Our units are not squared on those ones. If you guys need help, come to one of our live tutoring sessions. I've got tutoring Tuesday, Thursday afternoons, Wednesday in the mornings on Zoom. Mr. Garcia has Monday, Friday in the morning, Wednesday in the afternoon, and Ms. Humphreys has also added a tutoring session Monday afternoons from 2 to 3. So we've got 7 tutoring sessions through the week for you guys. If you need another session, reach out to me, reach out to your teacher, ask if we can Zoom at another time. As long as I don't have meetings or I'm not tutoring for another one of my classes, I will probably be available to you. So let me know, message me on Remind, message me through Google Classroom. I miss you guys. I can't wait to see you again. Stay safe, make good choices. If you don't make good choices, learn from your mistakes, and do the best you can. We're all learning together. I'm really proud of you guys for your effort. Have a wonderful day. I miss you guys. Bye.